Lithium batteries have a high energy density, so they can store a lot of energy in a small volume, but they can go up in smoke when bad things happen. In this short video, we'll show you what can happen during one of those bad things, overcharging.
Excessive charging can bring on thermal runaway in a lithium battery. Most lithium batteries contain special circuits to prevent this problem. Here are a few examples of these circuits. The two long, narrow circuit boards are typical of what you find inside a lithium power pack, as might sit inside a laptop computer. The little pouch-type battery, which is from a toy, has one too. But for this demonstration, we've removed the protective circuits. For our test, we've connected a DC power supply across a lithium battery the same way as a battery charger would be connected. The maximum charge voltage for lithium cells is usually on the order of 4.5 volts. But we've got the DC supply cranked up much higher than that to show what happens with overcharging. Battery manufacturers also usually specify an optimum charging rate of no more than 0.8 of the rated current, and of course, we're ignoring that as well.
Normally, lithium-ion packs may see a total temperature rise of about 9 degrees Fahrenheit as they charge up. Keep that figure in mind as we do our overcharging. We've got a spot thermometer that we'll use to keep track of the battery temperature as things move along. Our first battery is from a laptop computer battery pack. A point to note is that lithium batteries are not trickle charged when they reach full capacity like other battery chemistries. That's because doing so causes plating of metallic lithium in the battery. What happens with metallic plating is that the charge currents force lithium ions to accumulate at the surface of the anode without being absorbed into the anode itself. The plated out lithium can eventually form short circuits between internal battery components.
And we're sort of seeing that with the laptop battery. The hottest spot on the battery, according to our spot thermometer, is near the anode. Also, with prolonged overcharging, the battery cathode material becomes unstable and produces carbon dioxide. The pressure inside the cell rises. Eventually, the pressure rises enough to pop the battery casing at about 500 psi. At this point, the cell vents, and it may vent with flames.
As you see, our laptop battery got really hot and eventually vented. We didn't get flames, but we certainly got a lot of smoke.
Remember that venting as we power up our second battery, a small pouch battery that once powered a toy. Pouch batteries obviously don't have the metal cases like laptop batteries, so there's no opportunity for a seal to break and release pressure when the battery heats up. With this little pouch battery, we didn't get a lengthy buildup of carbon dioxide gas that happened in the laptop cell. This one went like a party popper in about a minute.
Wow! Awesome! That was awesome. GoPro though. That was awesome.
That was a great one.
Yeah, it didn't take very long.
No.
And luckily we got another one.
Our final test is of a somewhat bigger pouch battery, which also came from a toy. This one took a bit longer to heat up and build up pressure. While we wait, now might be a good time to mention that the reason for these big reactions is that the lithium is highly reactive. It belongs to the alkali metal group.
When we're overcharging the battery like this, we're causing a small fault or damage to the extremely thin separators that keep the elements of the battery apart. That's what leads to an internal short circuit and a buildup of heat. Heat buildup in one cell can affect others in the nearby vicinity, which is why groups of cells in some electric vehicle battery packs are kept in separate protective compartments.
It's exiting somewhere.
Oh, I see it.
That's
It's
what's
coming
that.
out.
Oh! Wow! Holy crap!
Now that was pretty catastrophic.
To summarize what we've seen here, when you charge lithium batteries, don't do what we did. Charge the battery at a moderate temperature, make sure the battery has a circuit that prevents overcharging, and stop charging if the battery heats up very much.
For more videos, go to eeworldonline.com.